PTU Nanolab disposes of advanced technical equipment and is one of the very few universities with an ISO 9001 certified clean room.
For that, we turn to private foundries, mostly located in Asia, and in particular, we use TSMC Foundry that is located in Taiwan.
Good afternoon, everybody, and warm welcome to this first deep dive of the EuroTech Universities Alliance. My name is Tatiana Panteli, and I'm head of the EuroTech Brussels office. Welcome to our speakers and our guests. First of all, to just mention the universities that are members of our alliance. They are Technical University of Denmark, École Polytechnique de Paris, Eindhoven University of Technology, Technical University of Munich, as well as École Polytechnique Fédérale de Lausanne and Technion from Israel. With this event, we are introducing a new model of policy dialogue sessions called deep dives. And we are planning 2 more deep dives this year in autumn. And we chose the topics of sustainability and innovation. So please watch our announcements. We will definitely invite you to our future event, and we hope that you will like this model because this will allow us in-depth examination and analysis of specific topics of interest to the society, academia, policymakers, and innovators, of course. In this first deep dive, though, we are focusing on the semiconductors and the European Chips Act. We felt that it was an important development both at the EU level and nationally, as the member states are currently designing national strategies to increase their industrial production capacity to reduce their dependencies on international corporations. The demand for semiconductors is high, we all know this, and there are a lot of questions to answer, like what kind of chips we need, what our R&D sector should do to accelerate development of the European chip industry. But for this event specifically, though, we will focus on the role of the universities in educating engineers of the future. And this is in response to the EU vision to become a leader in semiconductor technologies. So welcome to this event. Watch the space for the 2 new deep dives in autumn. And also I would like already to invite you to the EuroTech University's summer reception, which will take place on the 20th of June in the Residence Palace. And we will send you invitations. It will be nice to see you in our first physical event after difficult times in COVID, so it will be really nice to see you all there. And with this, I would like to welcome Tasmin Rose, who will moderate the panel discussion and this event as a whole on today's topic and will lead you through the program. Tamsin, over to you.
Thank you very much, Tatiana. And as we've heard, today's event is focusing on the semiconductors and our chips. And that, of course, makes sense that our hashtag for those of you who are using social media is Chips for EU. So please feel free to use that if you are tweeting and if you're writing mentions on social media. This event is live streamed on YouTube. It will be recorded and will be available afterwards to watch on YouTube, so you can share it and disseminate it more widely with colleagues. Just to give you a context of what we're going to be doing, we will start with an intervention from Nathalie Seguin-Moreau from the École Polytechnique de Paris, and she's going to give the context, set the scene for us, understand the socioeconomic impact of chips, the different types of chips, how they're used. She's also going to make the link to how the Chips Act for Europe could shape the research agenda. And then I have a very exciting and very well qualified panel. I have Jörg Hübner, the director for the Center for Nanofabrication and Characterization at DTU, I have Pierre Arnaud Brou, who is from the Commissioner Vestager's cabinet and has responsibility for industrial policy and SME strategy. I have Daniel Pitticht, who's Professor for Technical Education at the Technical University at Munich. And I have the Member of the European Parliament, Mrs. Pene Weiss. And I'm going to ask each of them a couple of questions, and then I'm going to open the floor to the audience. And we rely on you to put forward your questions. So please, you can see if you go onto Slido, you're using the Chips for EU hashtag, that's where you'll put questions, and you should, on the live streaming that you're seeing, you should already see the link to the questions. So as our speakers are talking, I'll be keeping an eye on the questions you've put in, and when it's the moment for me to bring in those questions, I will do so. If you put a question and you know already for a specific speaker, please let us know. If not, I'll just take the question, I'll ask who on the panel wants to respond. So that's going to be the framework for the afternoon. And now I'm delighted to hand the floor to Nathalie Seguin-Moreau, who's going to give us the scene setting and the context so we understand our background. Nathalie, the floor is for you.
So, hello. So you're going to share the slides? Okay, so hello to everyone. Yes, I'm going to give an overall picture of the microelectronics design from an university perspective. So next slide, please. Okay, so clearly we have chips everywhere in our private life and also in our professional lives. So we have chips in our camera, in our computer, but also in the instruments that are used for medical imaging. And so this is from the 60s, and there are more and more transistors inside these chips. And in particular, you can see with this iPhone 13 that now we have about 15 billions of transistors inside this ASIC. So it's quite amazing. Next slide, please. In fact, there are two different types of chips. So there are the digital chips that equip the current electronics devices, such as computers, cell phones, and so on, and which are subject to very massive production. And they are, so these digital chips handles process signals to two levels of signals, 0 or 1, so on or off, let's say, signals. And there are also chips that process analog or mixed signals, so analog chips, so which are used for medical imaging in cars, for telecommunications, and also for our research in high energy physics for the ASICs that are designed in such a field. So this plot that you can see here, so the semiconductor market for different type of chips, in particular for digital and analog chips, which are surrounded here. And you can see that there is a general growth for all types of ASICs. So it's not only for digital ASICs, but it's also for analog chips. Next slide, please. Okay, so you all know these Moore's laws that predict the number of transistors per chips that is supposed to double every 2 years. And so that's why there are more and more transistors inside the chips. So the technologies also are getting thinner and thinner. So this technological noise corresponds to the size of the gate of the transistor. So now we are using nodes which are smaller than 10 nanometer, which is very important for high speed and low power digital circuits, because the smaller the nodes, the faster the circuit. But anyway, even if these small nodes are crucial for digital circuits, larger nodes like 65 nanometer or 130 nanometers remain crucial for analog chips that are used for medical imaging instruments, but also for the autonomous cars, for the industrial automation, and so on. Next slide, please. So right now, 70% of the wafers fabrication is located in Asia. And what is interesting is the plot that is shown on the right side, because you can see the chips production along the years since the 90s. And you see that in 1990, USA and Europe were big producers of wafers, so they ensure 40% of the productions. And then you see that along the years, this involvement decreases a lot, and that now these activities is done by Asia mainly. So we have to understand why it is like this. So why foundries that in principle use very little manpower because it is a highly automative process, why foundries are successful in Asia and not in Europe anymore. And we have also to understand the links between the Europe foundries and the European universities that have been so tenuous in these last years. So next slide, please. So in the European Chips Act, so there are 5 strategic objectives that are listed. So the objective is first to strengthen the research and the technology leaderships. The second one is to reinforce Europe's capacity to innovate in the design, the manufacturing, and also the packaging of the advanced chips, which is also an important part. The third one is to increase the Europe's production capacity by 2030. The fourth one is to address the skills shortage and to attract new talents and to support the emergence of a skills workforce. And the fifth one is to develop an in-depth understanding of the global semiconductor supply chain. Next slide, please. So universities and research labs have a role to play in order to have a better leadership in Europe in semiconductor. So the first point is, of course, that it is important to have talented and highly specialized engineers in order to ensure a strong European semiconductor industries. For this high-level education in microelectronics designs, so the universities and the research lab has clearly a role to play, and we think that it's important that the teachers have also design activity for research in order to ensure that they are also at the cutting edge of the state of the art of the design. So the microelectronics public prize have to train the students, so through teaching, but also through internships and also PhD supervising. But it's also very important to be able to keep some of these engineers in our research labs, because the system wouldn't work. So this is illustrated on this photo on the right side of this slide. So it's important to have a very good interaction between the research world, the industrial world, and the education. And an important thing is that we should increase the attractiveness of the research labs so that engineers will stay in our labs instead of going work in the industry. And we think also that an important thing will be that all the European industries, I mean those that will fabricate the wafers or will perform the packaging, and that will benefit from the CHIPS Act funds, they should be required to forge or to maintain strong links with the research lab and the universities. So that's all for me.
Thank you very much, Nathalie. You gave us a really good sort of background to understand just how ubiquitous chips are in every different part of our life, and that also there are these two sort of very different types of chips, the very small ones and also the larger ones. And so we're going to have a little bit of a conversation about those two. And then finally, I think you really highlighted the importance that we need to have both universities where we have the facilities, the microelectronic labs, and the research leaders to help train engineers of the future, but also that companies that are going to benefit from the investment environment from the CHIPS Act should create and invest and have relationships with universities in order to help feed this process of engineers coming through. So you've given us a really good background to our conversation. Thank you, Nathalie. Let me now pass to the first person on my panel, and that's Jörg Hübner, the Director for the Center for Nanofabrication and Characterization at the DTU. My question here is, the digital transition is not just happening in Europe, it's a truly global phenomenon. And any region that can ensure a steady supply of chips can assure their competitive future. Are there any areas right now where Europe has a research advantage in relationship to chips?
I think there are several advantages for Europe at this point, and one obvious advantage is equipment manufacturing with basically a monopoly in state-of-the-art lithographic equipment. I also think that especially analog and automotive chips, Europe has a stronghold there. But I think we are lacking in cutting-edge node digital and logic chips. We are lacking the overall expertise to go down into the very small nodes.
Analog, we've got a bit of a good background, but it's the very small, the sort of very cutting edge small chips that we've got an issue. Now that leads me to a question. Should we be prioritizing research into these most advanced chips that are less than 20 nanometers, or the chips for everyday use where we already have a bit of an advantage? What are the pros and cons of each different approach?
I think clearly we have to move into a smaller node, or at least specialized chips for optimized, for example, for energy consumption and digital logic chips, because it's where the growth is. There is also, of course, growth in analog and the trailing edge chips, but the main growth in the coming times will be in cutting edge chips. So Europe has to move into that area to be the player that we want to be and that we have to be, given the strategic and economic situation and the constraints that we are under. That chips are basically going into everything that consumes electrical energy, and we want to produce also in the future things that consume electrical energy.
Yes, when you put it that way, it becomes very clear just how much we need to invest. Chips are used in anything that uses electrical energy, and pretty much everything uses electrical energy. So you can see just how ubiquitous in our everyday life chips are going to be. Let me now turn to Pierre-Arnaud Proux, who's from the cabinet of Commissioner Vestager, who has responsibility for this. The Commissioner just published the Digital Chips Act. What are the key goals that you want to achieve through the Chips Act?
Yes, thank you very much, and thanks for hosting this event. It's true that the semiconductors and chips, they were not on top of the political agenda for quite some time, even if there were some initiative by the EU already a decade ago, but it changed radically. And I'd like to talk a bit more about the context. And Nathalie and Seguin-Moreau already said chips are needed virtually everywhere, and it will be more and more the case. And that's what we realize during the current shortage of chips. And that was a very interesting and important lesson for all the political world. And the second one is also that the semiconductor supply chain is extremely concentrated, and especially some parts of it, but globally it's extremely concentrated in the hands of a very limited number of companies and also a very limited number of geographies. And we have a geopolitical context which makes that the risk. So that was the context, that was the point for the reflection of the EU institution. And based on that, our ambition can be given two main points instead of maybe five, and which have already been explained. The first one is that we want to increase the production of chips in the EU, but we want to reinforce all the different steps of the value chain. But it doesn't mean that we want to do everything in the EU, so that's a very important point. We'll keep, of course, a dependency with other parts of the world, but we want something a bit more balanced between geographies. And the second objective, which may be less prominent in the CHIPS Act itself, but which is very much related to the importance of chips, is also that we want to facilitate the adoption of chips, and especially new generation of chips, by the EU industry as a whole, because we see that as a key concern for competitiveness of EU industry, be it, of course, automotive, as we talk a lot about it, but also health industry, sorry, or basically many consumer goods which will require chips. So that's really our ambition.
Thank you very much, and I apologize to our audience. We lost connection with the first few sentences. I think the connection was not very stable, but you were talking about the fact that at the moment it's very geographically focused, the semiconductor industry at the moment, and this of course creates both opportunities and risks. And I think given the situation we're all living through at the moment in Europe with the conflict right on our borders, we're understanding the risks of having an industry concentrated in one area. So if I could now invite you to speak a little bit more about the research dimensions of the CHIPS Act, because obviously here we've got a network of universities. We want to understand what's their role in this picture. We heard from Nathalie that we need to train more engineers. We need to have universities that are able to train the engineers of the future, but we also need the industries that are going to benefit from the Act to create links and relationships with universities and create partnerships. So what do you see for the universities in the CHIPS Act?
Expectations are high for universities, so we see them as contributors and as also beneficiaries of the Act. And I have to say, so I did not describe the proposal itself, but the first pillar is the Chips for Europe initiative, and it's very much focused on research. So we have leading universities, we have leading research organizations in the EU, and we want to give them ways to continue their research and to keep their leadership. And we also want to bring this research closer to the industry. So as we often say, bridge the gap between the lab and the fab, or research and production. And here in this Chips for Europe initiative, where in fact the real EU money will go, we'll bring some concrete initiative like a design platform that will be available for all industry, but to which we hope that academies and research organizations can participate, but that they can also use it for their own research, and also pilot lines. And that's very important because these pilot lines, they will be set up by research organization, and they will need help also from other universities or other smaller research organizations which have their own specialties in the field. And we also think that they should use also these facilities. We also want to create a competence center in the EU, which will help companies to use also these facilities and this design platform. And here we hope also very much that the research organization and academics can participate and also help the industry. And of course, what we need is the skill. And here I very much agree that the role to play, but I also thought that the industry also has a role to play, and that they can also finance PhDs, that they can finance also a traineeship. So it's a dual contribution, and I very much also agree that academia should keep staff talent, also share also with industry. So the objective is that you can also train people for other. But I wanted to say one last word on skills. So we need very, very qualified and specialized engineers. That's clear. But I also think that we need to have more people, a bit more ships aware in the industry. And here I think as well, even if we don't form like specialized engineers, I think that academia's research organizations, they also can have a role to play to help getting more conscience of the importance of ships and the use that can be done by industry.
Okay.
Thank you.
Thank you very much, Pierre. Apologies, yes. Thank you very much. And I just wanted to say thank you for the questions that we're starting to see coming in. I'll be coming to those in a moment, but I've seen several that are really relevant for our speakers. I'd now like to bring in Daniel Pitik, Professor for Technical Education at the Technical University of Munich. If we think of chips as the hardware that are driving the digital revolution, what about the software, meaning the skills and the training to build the innovation cycles to develop and use the chips? Now, that's already been touched on by Pierre Arnaud, but can you talk to us a little bit more about how we develop and train that? Are Europe's science and technology universities well positioned to create a pipeline of highly skilled workers and engineers?
Thank you for the invitation. I think universities and especially research in the overlap of technology and humans are supposed to hold, as you have mentioned, a key role in the implementation of technical innovations in order to save and develop our production system and society. If we follow this argumentation, technical universities like TUM have not just the mission to develop new technologies and processes, but also they have a social mandate to integrate technical innovation into the society and especially into the people's heads. And the key aspect is the idea of human-centered engineering. And it's a broad field, and besides others, the topic of upskilling is central. And that puts a focus on education or teaching and learning approaches in the interdisciplinary field of technical education. So research and teaching takes place between engineering and social or human or educational sciences. And in this interdisciplinary context, we as a team of TUM Technical Education are located. The aim of our work is to prepare people for the implementation, usage, and application of technical innovations like chips, and thus to save or to develop our production system and society further. And to create a pipeline, to use your word, of highly skilled workers. Skills, competencies, or qualifications, however you would like to call it in technical domains, this is exactly what is our all-day business in the projects. And we already apply it, not just in a small segment of engineering or engineers, but especially by focusing on the field of vocational education with our networks, collaborations, programs for the technical teachers in vocational education. Our responsibility and area of impact is very broad and reaches people on different levels throughout our production system. We see that beside all the effort, technical education as a core idea in research and teaching in order to support people in their own development should be addressed more intensively.
Thank you. Let's just talk a little bit about the sort of shelf life of skills. the speed of technological change means that skills now have a very short half-life, a short shelf life. So how can universities reinvent themselves to accompany industry and workers with this continuous skill building? Because not only do they have to be able to train, but they themselves have to continuously train themselves so that they are able to train the next generation. Somebody who's been out of industry in academic world, are they now out of date after 5 years? How do we keep maintaining at the cutting edge of what's happening in industry so that the skills that and the curricula are appropriate?
For me, the key aspect in education of engineers and vocational experts is the consistent and coherent implementation of competence orientation, because competencies can be understood as an individual or subject-related tool that is supposed to react to changing environments and activities in our production system, as you have mentioned. And as you have highlighted, this is more necessary than ever because innovation cycles are getting faster and thus the needed qualification change in the same speed. If we do not implement competence or an orientation that focus on individuals in initial and lifelong learning formats, the gap between the technologies and the competent individuals is growing. And insight in our programs and courses show that a coherent competence orientation can hardly be identified, and that mainly the technical skills or competences of an engineer or skilled worker are focused. But through the discussion in our networks and around our projects like EuroTech, the industry and the expert feedback shows, as we all know, that there is a high need to include and promote other skill aspects in technical domains as well. And for a comprehensive approach, we have to include the so-called 21st century skills and the soft skills and combine them with the technical ones as aims of a coherent development and address them in corresponding development approaches using up-to-date methods. And for this, it is necessary to break down the relevant skills. It is not sufficient to talk about digital competencies. You have to fill these facets of skills with content, or in other words, you have to make them concrete. Otherwise, it's not possible to address them in the human's development in a structured way. And we at TUM have done a lot of research and concrete implementation, especially on this topic. We have developed a unique approach that integrates, on the one hand, higher and vocational education in technical domains. On the other hand, it is based on a close collaboration with schools, ministries, agencies, and companies from industry and small and middle-sized enterprises in our projects and our all-day business. And in this approach, research and its implementation go hand in hand, and they enrich each other. And I would really appreciate to discuss and reflect on our approaches in detail in the follow-up, because I see this talk just as a starting point. But one thing seems obvious to me. If we or the universities want to proceed in the field of technical education, we all need to move. We need to move on, and we have to leave the ivory tower. We have to go into practice. We have to collaborate. We have to discuss. We have to listen to the people's ideas and challenges, and offer supportive as well as implementable approaches regarding the current and future innovations. And this will lead to an ongoing change in the benefits for the people, our production system, and our society.
Thank you very much, Danielle. A very clear message on both the importance of upskilling in the universities, but also remaining completely relevant to the kinds of competencies and understandings that both students and the professors and the teachers need to have. Let me now bring in the final member of my panel. That's a member of the European Parliament joining us from Strasbourg, presumably as a plenary session going on. So it's Mrs. Pernille Weiss. let me now ask you, the CHIPS Act is a way of leveraging the state aid regime to meet our strategic economic goals. And we heard right at the beginning that Europe doesn't have the position that it wants in terms of strategic autonomy or leadership in this area. So in your view, the CHIPS Act and using the sort of state aid regime to leverage this position, is this a sustainable solution to the chronic shortage of chips that we heard about earlier that is holding back our industrial development?
Thank you. Thank you for giving me the floor, and thank you also for inviting me to this very, very important event. Because yes, we need to get out of this chronic situation, as you describe it. Both EU and US is lagging behind, and we cannot do what we have promised the next generation and the coming generations of a more healthy, greener, more sustainable Europe that leads by our example the rest of the globe in the right direction. We need this twin transition of both the green and the digital transition to move faster and better, not only by our promises and higher ambitions, but actually also by providing the toolboxes that are needed. And there, semiconductors, the chips is core and essential to that. And I think also that I speak on almost behalf of the whole Parliament when we say that we have waited for this CHIPS Act for very, very long. And also that we applaud that now we have it, and that the negotiations in the plenary, between the parliamentary groups have now started. And what we really want in order to succeed the goals, but also in order to, I mean, coming from my political family, the Danish Conservatives and the European People's Party, we accept to use state aid when it's needed, but it's a tool to move any challenge into a sustainable and self-sufficient situation, as we did in Denmark with the windmills. That you see there is a missing link in the market that we need to push forward in order to provide a strong economy and the toolbox of technologies needed to do so. But saying that, it's also a couple of minutes to 12. So we hope that this act will swiftly be adopted. That is very, very crucial for this term that we finalize during 22. Hopefully then that can be adopted and put into use in 23, 24-ish. So that both the environments on universities of research and development, innovation, because that is where EU still is very strong. That's the core essence of being a European, that we like to research. We like to question whether we can do tomorrow better than we do right now. And in research and development, we have a strong tradition and culture for doing so. So we just need to go back to what we are best at, namely research and development as the one part of the CHIPS Act, but also by when we do it, that we provide a healthy and coherent ecosystem that also includes the SMEs of all scales and sizes, as well as also that we do it in a way where we focus on skills and also how we can leverage the competences needed along the way. Because we have also to be realistic that it's better to work step by step in the ecosystem so that we create kind of an optimistic ripple effect, so that we do not overburden with too many expectations and too few financial tools and steps along the way to have the needed skills for every different kind of sector in the future, hopefully. I think I will stop here because I know you have a question number 2.
I do indeed, and basically, I wanted to know, how do we fund this? This vision change is absolutely huge, as you say. We're 2 minutes to midnight. Europe is lagging behind, and yet this is so strategically important to the vision of the kind of industry, the kind of society, the kind of lifestyles we want to have. So, how do we invest in this? How do we fund the CHIPS Act?
That's a very good question. And we need both the public and private funds to work together. And there are suggestions in the Act from the Commission side that addresses these issues here. And it's a huge amount of money that we actually need. I don't think I've heard that in the panel so far, but I saw yesterday someone making this estimation that if we set the goal that the EU should actually have 20% of the global chips production in 2030, then it takes several hundred billions of euro to do so. And that is also why we have to be very careful how we fund the pillars, as well as also that we do it on the frameworks of the Horizon Europe Excellence. And that goes for a lot of other investment issues that we need to see public and private finance to go hand in hand. I really would like to underline that very, very much. And I also will not waste this opportunity also to underline that besides what we do in between the EU institutions, and I know, of course, the Council is a part of that, but added to that, that also in the Council, there is a gentleman agreement, at least, that in order for the national budgets for research and the national initiatives to have more women in STEM, but also to work much more closely with the digital skills transition in every sector in the member states on the core industries that are represented in each country. There, I would very much like to see more performance. And it's not about me coming from a Nordic country saying we know what to do and we are the leading role models here. If we look very closely to the national budgets on research to the universities, they do not, in average, present 3% of the annual fiscal budget. And that is a problem. I mean, both to the right and to the left of the European continent, US, China, Korea, Japan, etc., are using more money on the universities, on research, on education, and that cannot go on. And that is also why I would like to just do a little alert on the negotiations of the CHIPS Act that don't even think that solves all problems. There are other initiatives, other obligations that flies a little bit under the radar in the member states that needs to be polished and speeded up in action. Sorry to be so blunt, but I think it's important to do that now also because we are addressing the next generation of young people looking at us. They know that it's that we're talking about a green and a digital transition. All young people deciding what education they want to do are referring to either they want to save the climate or they want to be a part of the digital innovative future. And we need that for the CHIPS Act. So let's use the lingo also when we address how to finance this, that they can see by the end of the day, I can also get a job, either in a public and a private sector. And also coming from my political family, I hope to see more private enterprises and more private jobs to be created in the outcome of the CHIPS Act. And therefore also I need to underline that when we talk about financing side by side with some of the other parts of the CHIPS Act proposal, that we need to be very careful not to overburden the SMEs with a lot of extra obligations that are out of proportion and doesn't add to the value to the ecosystem development of semiconductors in general, but also that that SMEs of all colors and all specific profiles, especially in the time we are living in right now, post-COVID recovery, we are at war and the climate targets are still getting higher and higher because we are getting closer and closer with less and less time in front of us. We need also the SMEs to really take the positive yes hat on and invite chips in their industries, in their branches, because they can see a smooth, easy way to do it. and also easy accessible answers to how to get their initiatives funded, but also where to get the skills to their workers.
Thank you, Pernille. I think it was a very interesting and very important recall to everyone that, you know, of the OECD countries, very few in Europe are anywhere near the 3% investment of GDP in research and development.
Exactly.
And
Exactly.
that partly explains where we are competitively to other parts of the world, which invest a lot more.
Exactly. Exactly.
So let me now bring in some of the questions, and the chat is really filling up. I've got lots of questions. The first one I'd like to bring in, and we've got a couple of them highlighted on the screen, and let's start with the one about, you know, what is the EU strategy about? Are we trying to get US and Taiwan chip leaders to come to Europe? Or are we trying to create our own European unicorn, if you like, to have industrial leads in Europe that are closely linked to the R&D network? So maybe Pierre-Arnaud, I could invite you to look at this from a political perspective from the Commission. What are you hoping to achieve? And then maybe Jörg, you might also like to reflect on this. But Pierre-Arnaud, what are we trying to do? Attract to Europe the lead Chinese, Taiwan, US to come and create their filiales here? So at least get a toe in the market, or we're actually trying to create European industrial champions?
What we are trying to do is to secure the supply chain very shortly, as I explained before. And for that, what we want to attract in particular are all these first-of-a-kind project, as we explain in the CHIPS Act. So project of an innovative nature, but it can be in different ways. It can be smaller nodes, it can be many different other innovation, power efficiency, and so on and so forth. So then you just have to look at who can deliver. And some of these projects may be for European companies, but some other may be for big international players. There are already doubts, for example, in the market that Intel itself could make these smaller nodes. So I don't think that any current or coming EU industrial players could do it, but we will look at all projects. And I'm sure that there will be both international and European projects. But the objective is not to create a European champion from the scratch. That's clear.
Thank you, Jörg. Maybe could I bring you in? We also had a related question to say, are we competing with or working with the US on semiconductor R&D? So perhaps you might like to reflect on that as well when you're looking to see, should we be going for European champions or to attract US or Taiwanese leaders to Europe? And then are we competing or collaborating? You're on mute.
Sorry, thank you. Yeah, that's a very good question, and I think the immediate answer, and I will come also a little bit to the skill building there, because it's very important also in this respect, is that we have to build clusters, because everything everything that is big around, especially this very diversified, very specialized industry, is to have a cluster around. So if we have, the more we have, the easier is it to develop. There's a snowball effect in that kind of because it's complex, and part of this cluster is, of course, trying to get initiatives and grow them. Maybe also regarding newer chips and newer technologies, but also build on what is there and invite the leading companies to be here. And that cluster will exchange knowledge and workforce and skills, and then we can build on each other there. It's also important, I think, concerning the skills, because one of the, in the bottom of the pyramid, there's the qualified workforce. Without the qualified workforce, we'll not get anywhere in building a chips industry in Europe. And it is extremely complex world to build chips. I have said that before, and I'm repeating myself here, but there's a saying in this industry that making chips is not rocket science. It's much more complicated, and therefore this means that that when we want to educate engineers, we have, and it's a hands-on training. It doesn't, for the chip manufacturing, it is a hands-on training. We cannot, or there's no immediate use in theoretical education in chip manufacturing. It is inside the clean room at the machines that we have to educate these engineers. And these machines have to be state-of-the-art if we want to educate state-of-the-art engineers. And these machines are expensive and the clean rooms are expensive. So we have to build the capacity to educate these engineers inside the clean rooms at state-of-the-art tools with necessary throughput. That means that means we have to have the capacity to educate these engineers, and we have to start to build this capacity as soon as possible, because as we are at the bottom of the food chain here with the skills, it takes 5 years to produce an engineer, and if we go even higher, because a lot of them will need PhDs to solve these challenges. So it's another 3 years, and of course we can kind of cross-train, and a lot of master level candidates will be qualified to take up a PhD in semiconductor manufacturing, but it's at least 3 years until we have the PhDs out in the other end. So I think this is an important factor to build the whole thing up, that we create capacity for education, and of course we have to have the research-based and skill-based teachers and professors to do that, and I think we have many of them around. There are also very good people in industry that can help, but it then again needs a collaboration, industry, university, to build these kind of skills. When we have these skills, and we get big companies in to do cutting-edge nodes into Europe, and we're starting to build other, maybe more newer technologies up in Europe from scratch, then we have brought things together, and then we start rolling, and we can actually create this snowball effect. And of course, it needs also the other things that are mentioned in the CHIP Act. It needs subsidizing from in finding locations. There has to be fast subsidization of like all the things they also do in the US and Asia to put money into the system. They have to be also there, because otherwise we'll be outcompeted.
Thank you. And Nathalie, I saw you nodding a couple of times as Jörg was speaking. Is there anything you might want to add on that?
Sorry?
You were nodding as
Yes.
Jörg was speaking, so I could see that you agreed, especially when he was saying, look, universities, you have to have the clean rooms. You've got to be you've got to have the spaces for engineers to actually get hands on and do this. So you have to invest in that. You've got to keep up to date. So, and I could see you nodding. So I wondered if you wanted to add in about the comment there on what he was saying about the role of universities acting as a magnet for talent, but they need to have the physical capacities in the infrastructure to offer that cutting edge space.
For us, for the design itself, we don't need a specific facilities, because we use software and so on. But I think it's yes, education of talented engineers is very important. And so this is something that we can do through internships, PhDs, teaching, as said before. So it's very important to have high-level educated engineers, but we don't need specific facilities in our case.
Thank you, Danielle. Danielle and Jörg, you've both got your hands back in. So Danielle, go ahead, and then I'll come back to you, Jörg.
So maybe I can jump in there what Jörg said. What we see in different initiatives around Europe and around different levels in our educational system, that this is exactly what is going on. The institutions are trying to find approaches, or building up rooms and then finding approaches where a connection between knowledge and understanding and the application of the knowledge takes place. For example, as you know, at DTU, at Autumn, they are working on project-based learning approaches. And I think this is a kind of the future of learning in technical domains. On the one hand, to stay resilient, we have to have these backgrounds which come from universities, from our professors who are doing research in this field. But on the other hand, we need the companies, because they know exactly how the application of the understanding of the knowledge of the backgrounds, how they look like. And this is how we like to work, or how we work in the EuroTech project. We want to bring together the people's experience and expertise to say, how does the field of action or the environment of work looks like? And we have to sort the ideas of knowledge of the things which are necessary to act in a competent way in these environments. These have to come from universities, because this is their big strengths. So it's all about bringing the people together, combining different expertise, so that we create these workforce. Jörg already mentioned several times in his ideas.
Thank you. Jörg, go ahead.
Yeah, I think first of all, I think we have to make a very clear distinction here between chip design and chip manufacturing, because it's completely right what Nathalie says. If we're talking about design, which is as important as manufacturing, because if there's nobody designing chips, we don't know what we should manufacture. So and there's a lot of IP and knowledge in chip design as well. But for chip design, it is software. But for manufacturing, if we want to have the fabs here in Europe, it is absolutely necessary that we have the skills and the facilities to educate these hands-on engineers inside the clean room. Now here at the DTU, we have done that for more than 20 years now. We're actually educating from the bachelor level engineers on machines that are also used for production for companies. So we're putting these students together at the same machine in the same clean room with companies that are manufacturing on the same machines. That has a lot of challenges for us running a clean room and doing these, because things can go wrong. But the benefit is there immediately, because the benefit is what Daniel says, and the other benefit is these companies, they can hire the students as engineers, and they are already trained at the machines that are used for production and development. And training engineers for an industry in the clean room is extremely expensive. At our clean room, it costs around €100 an hour to be in there, plus the machines that is used. So if we have a company that has to hire an electrical engineer and train her completely up in the clean room, inside the clean room, for a year or so, because that's what it takes, there's a huge threshold to do that. But if we have engineers that are already trained and they have seen it, maybe they have seen these engineers in the clean room, they know each other on beforehand, they are put to relevant tasks, they know what the industry wants, what they like to see, then the whole thing is going very much faster and is accelerated, and everybody knows what he or she gets when people are leaving the university and going into industry and production. So this is enormously accelerating and lowering the threshold to get started with production, because it's lowering the investment in people.
Thank you. Daniel, did you want to add a quick last point before we move on to the next question?
Maybe just an additional short idea. We are currently working exactly with these ideas to find out and to combine the research on finding the new and relevant skills by combining research on skills or competencies in the processes of developing new technologies, for example, in additive manufacturing. And I think this could be something very, very relevant and interesting for other technical innovations, to combine the processes of the development of new innovation in technologies, for example, chips, with the findings or the research on what skills and competence are needed in these technologies areas.
Thank you. Let me now move on to another topic. And we've had a couple of questions in the chat. And Pernille, I'm going to come to you because you mentioned the green transition and the digital transition. And a couple of our questions have come forward specifically looking at this balance between sustainability and environment and the digital transition. And so let me give you two questions that I think are worth exploring. Is the EU considering the possibility of a more ambitious, new, greener or more sustainable infrastructure for producing chips beyond state-of-the-art production? So this is precisely to say, are we, instead of just saying state-of-the-art, so latest design, but looking for ways to make them really at the forefront of the green transition as well?
That's a very interesting question and very relevant. And I don't think it makes sense to say no to that. Also because when we talk about ecosystems, and also as described by Jörg, this co-creation between businesses and students and researchers, we need to work on the infrastructure. And we have the green transition as the absolute not hot potato, but it's a plate that becomes more and more hot, because it's not something that we die from next week. And every challenge that can be put to the next day's schedule or to next week's schedule, they just grow in their explosiveness. So I think it's very, very crucial that we focus on also the climate-related infrastructures, and and that is where I hope to see maybe some amendments to the CHIPS Act coming forward and being sent to the European Parliament, but also that we, after the CHIPS Act has been adopted, hopefully also it entails this idea coming from the EU climate law of climate partnerships. And I think that we should have partnerships on semiconductor industries, in order also to have the best framework of agility between researchers, industries, and how what we cannot foresee will be challenges in the future or opportunities in the future, that we can react on them immediately. And that is also a part of the infrastructure of policy and co-creation in between institutions, private and public, is specifically focused on how to reach the climate goals by being a leading example of how we do it, but also because the consequences of the climate change will have a strength and that will outplay the pandemic many, many times, but we don't envision that yet. But I think we have to take that threat more serious as we do now. And the proposal of infrastructure focus is relevant in that respect, also to be that it's possible to take the infrastructure approach and prioritize where do we get the best cost efficiency and cost benefit of what we can do. Because it's not only a matter of state aid of the size needed, but also how we actually can swallow the elephant in the way that we create kind of a ripple effect, but also a clever snowball effect, that we start the right place.
Thank you. And on a related issue, we had another comment to say that, many devices actually have multiple chips inside them. And do we have a risk of creating, a huge new waste pile of chips, given that it isn't as simple as one chip, one device. One device might have multiple chips in, and we might be, if we race to create more chips, we might be creating a new problem, just like we had to create the WE directive dealing with electronic waste, a decade ago.
Well, there hopefully we are helped by both the policy and the tools of circular economy, that we are not longer talking and thinking linear, but also that the global political changes, both because of the corona and before that, the China-US battles on trade, we have learned bitterly how important it is also in terms of raw materials that we recycle, and also that we do better assessments of where to use resources that we have, but also that we design new products in ways that we can defragmentize again and use the materials. I really hope that will not be the missing link of understanding, because we really need to do so. I'm working right now with the recasting of the waste shipment regulation, and that is actually one of the challenges in the recasting, how to make the European waste go in circles. Also, when they in the open economy go in as wide circles as it reaches third countries, both in and outside OECD. And that is where we have also in the frame of the Digital Chips Act, also some concerns to be paid on how we can grow a sustainable and reliable international cooperation, not only on research and innovation, but also how industries that are actually global in their core sense, that the way we open up and continue to open up the global competition in a healthy way, also not creates this bulk of waste of chips that are lying around, doing harm to the environment and also social issues.
Thank you. Pierre-Arnaud, I wonder if I can come back to you. Perhaps you'd like to comment on this challenge that we've just been speaking about, which is, balancing the digital and the green. We've understood the importance of investing heavily in chips, making sure we have that industry in Europe and the supply, but how do we balance that out with the green issues? And then we do have one question from the chat that's very specific to you, which says that the CHIPS Act allows extra support for first-of-a-kind facilities. Don't we need more than only the first new fab to reach 20% market share? So that's the second question. But first, maybe you could comment on this issue of getting the green and the digital balance right.
Yes, thank you. But first, I would say that we see the chips also as a tool to contribute to the green transition, because they can also help to save energy by themselves, the use that can be done. And second, I would also say that the chips themselves, they also have to improve their energy efficiency, and that's one of the way in which they could also research should go, and that will be part, I think, of the work of some academia and research organization. But then, of course, there is a question of the chips themselves at the end of life, and we should avoid indeed the piling up of material which is difficult to recycle. So that's also something that we will need to think about, and there are many horizontal tools. I think the member of parliament mentioned the waste management directive, but there are others also in the design of the chips that we may have to think more and more about it. And there are also research, I think, in the materials that can be used in the chips for the future that could also help us to solve a bit this issue. So, but I would not say it's simple, because it's not. But we think that we will come with proposals also to help in this regard. I see that Jörg has already raised his hand, so maybe I reply to the other question later as you want.
Okay, Jörg, if you want to come in on this, and then Pierre-Arnaud, I'll come back on the question of first and of kind.
Yes. One way or the other. Thank you. But I completely agree with Pierre, but I also could imagine that as an example of where the universities come in and where collaboration between industry and universities come in, because because there are used gases, there are used things in manufacturing that we know have a large carbon footprint, and that can be, at least principally, be avoided. But they are industry standard, and nobody, if you make chips and buy manufacturing plants for billions of euro, then nobody wants to take risks unless things are very, very, very carefully investigated. And these kind of investigations and experiments that are needed are kind of island projects for different processes that can be investigated by universities in collaboration with the big chip manufacturers. So there is in a way a good example for because at universities we cannot go into a big production line. The machines, the production lines are too expensive. We cannot run the same machines that cutting edge nodes are running with machines that cost 150 million euros. No university can afford these kind of machines and cannot afford running these machines. But we can solve problems that arises with these machines, and we can solve problems here and there. And these problems might as well be related to how to make a greener production and how to reduce the carbon footprint in the chip manufacturing. So this is a good example, I think, where one can have nice collaborations, efficient collaborations between universities and industry.
Excellent, thank you. Pierre-Arnaud, if I could invite you to come back and comment on this question about if you're going to invest in first of a kind, that makes sense, but don't we need more than just one big facility if we're going to try and reach the 20% market share by 2030?
Yes, no, it will not be easy to reach the 20% market share. So that's already a first remark that that's the objective, but that's definitely ambitious, and we are aware of that. But then on the question of first of a kind, I'd like to also liaise with a comment made by the member of parliament before on the investment needed. So we need, I don't know if it's hundreds, but we need dozens of billions of euros to manage to get to this 20% target. So the question there is, what is the role of public power in it? And the public power, we think in the Commission and public finance, they should focus on giving the tools to the industry. So that's a bit what we're discussing in the start, innovation and to have to train the skills, the workforce, so we have a positive environment for these new activities. And then we have to see what we really want to finance with funds. And then we think that we need to focus on first time, because that's really the project which are the most difficult for private investors to develop on. Simply because they are extremely capital intensive. You also have risk to take.
I'm sorry, Pierre, the connection is really cutting in and out. I wonder if you could switch your camera off, and maybe that would allow us to hear you more clearly.
Yes. Okay,
that's
I
better.
Switched off.
Thank you. Apologies.
No, sorry. We'll see how long it works. Yeah, so I was saying we've got to make a choice where we want to put the public funds. And we think that it makes very much sense to focus on first of a kind when we talk about public fundings, because that's where it's maybe a market failure. It's very hard for companies to find the money, because we are talking about very large investment, and to take the risk alone to make these production facilities. So here we really see a need for a public intervention to come and to provide enough aid, but not more, but enough aid so that the project can kick off. Then also, I mean, there will not be only one first of a kind. Huh? There will be a few, or at least we hope that there will be a few. We'll see what is really the interest from private investor, but we will have different projects. And for what is not first of a kind, by definition, it means it already exists in Europe at the moment. So what we think is that by giving the tools to the industry, they should have the possibility to develop themselves business models that have already proved to be resilient, and that they don't necessarily need additional public support as such for the production facilities.
Thank you, Pierre Arnaud. We have a question that's come from the audience, and I'm not sure who on the panel wants to pick up on this, but I think it's quite interesting, which is, talking about, how do we build the needed faculty or the capacity to develop the talent for chips? Because recently there's been such a focus on AI, quite legitimately, again, in the same case that the EU has found it's fallen behind in artificial intelligence research. It sees it as strategically important. We've had a lot of focus and initiatives on it, but that has, leaves universities perhaps with a difficult choice. Do they focus on the data, the AI, or do they focus on the physical, the hardware, the chips, etc.? And I don't know who from my panel might like to respond on that, but how do we get that balance right? Because AI got a lot of focus, and now we're saying chips, and are they incompatible as visions? Jorg or Daniel, I'm wondering if one of you, we might like to pick up on that, or Pernille as well, please.
Yeah, it's a difficult question. I think the trivial answer would be we have to focus on both in a way, and of course it is. I mean, I would say, but that's also because I'm biased from where I come from. We cannot use AI if we don't have any chips to run it on. So if we take a chicken egg problem, then we have to lay the egg first and then get the chicken out of it at some point. But I don't think it's an either or, because people are not universally interested, and there maybe Daniel might have a good idea on how to direct people to a certain area. I think already the attention that chips have received now due to the chip crisis and what we are doing right now, panels and news and so on, there is an interest for young people that they can kind of coin a little bit part of the world by doing what by being there and taking part of this and solving this crisis. And I think that will give us more people, and the faculty, of course, it's trained people, and we don't have but a lot of chip design, but then where's all the chip design taking place? It's actually most of the chip design is taking place in the US. So let us try to recruit a few people from where they design chips and where they have the capacity. Maybe some people from the industry abroad would like to have a nice faculty position and do something else. So I think we have to be creative and think where can we get that? Are there some extremely talented young people that we can promote a little bit faster? That in the academic circles we tend to be a little bit careful with promoting people and sitting people into a position of high responsibility. Maybe we can be a little bit faster there. All these kind of things I think we have to do all these kind of things in order to get there.
Thank you. And Daniel, just before I bring you in, we've had somebody comment from the audience to say they're both important, but the teacher's skill set are not the same. And I think that was the question that we was trying to be picking up on. It's clear that we need a huge number of engineers, whether they're data engineers, software engineers, or whether they're chips engineers. We clearly need more across that entire continuum that's able to operate in this area. But it's the teacher skill set that perhaps you might like to pick up on.
Yes, maybe first, in addition to what Jörg said and what Pernille already pointed out, is I think the only possibility we have is we have to increase the selection, and this should not just start in higher education. We should or have to start very early in these processes in primary education to open up the field, that we do not lose these talents. And I think the big chance is to bring in the technology and the things the people know. Yeah, in schools, the children know these chips, these platines, which are in their everyday artifacts, technical artifacts, we have to bring them to school and show them that it's not nothing. You already used the word, it's not rocket science. Yeah, it's something which you can learn and which is handle or which is possible to learn or to work with. And it's totally right that the competencies or the expertise of the teachers, they are growing all the time. But what we see is not the technical skills is a problem. It's very easy to have programs in upskilling in the technical fields. What dramatically changes is the aspect of information. And here we go into the field, what I mentioned as soft skills. Yeah, if you have a closer look at personal or social communicative competencies, this is where we have to make our teachers fit, because it's a different approach needed to learn or to generate these or to develop these competencies on the learner side. Yeah, and what I mentioned with the aspect of information, we need to educate the future experts in being prepared for having these huge possibilities to generate information and to find them and use them in their all-day business. And this is what dramatically changes in these new innovations. And this is where we have to focus on in teacher education, but also in the education of the skilled workers.
Thank you. We're coming towards the last sort of 7 or 8 minutes of our session today, and it's been very interesting. And I think I'd like to just close by asking a question that somebody in the audience has said, which has said, do we have a research agenda that's been developed, a consensus research agenda on what needs to happen? We've talked a lot about the role of universities as a place of training, as shortening the lab to the fab. We've talked about them as a magnet for skills. We've talked to them about, developing the workforce of the future. Do we have clarity on what a research agenda would look like to help deliver on the digital, the CHIPS Act? And if not, I assume this is a call for us to make a first step to get a consensus about, what the research community could do. And Panteli, I see you've got your finger up.
Yes, I would actually applaud that you do, because I think we are at the core root of what are one of the reasons for why we are in this chronic state of that we need semiconductors and chips. And also because we have kind of lured ourselves into a sleep in EU that research and excellence is something that doesn't need maintenance and doesn't need to be reiterated and articulated, especially in between member states and the EU institutions. We take it more or less for granted, and we don't also not all necessarily have this strong understanding of research is actually needed for us to tackle the current and the upcoming challenges that we see are there, and that a lot of politicians think we can solve by just raising the ambitions, saying someone should do something about it. So I think if we could also give the understanding of the European way of research a renaissance in the CHIPS Act, and as a strong part of how to bridge the twins, the green and the digital transition, that could really be something that also could unite us as citizens, as countries, in a way that we really need for the moment also. And that was my reflection when I heard the Q&A just before on how to engage also not only inside of universities and in between the universities, that we are talking about a huge amount of public money to be used in ways that can make others envy, but also that can create misunderstandings amongst some public stakeholders. And also, in order to prevent that grows in the political environment in a populistic way. Also, therefore, it serves a purpose that we open up as much as we can without destroying confidentiality and the potential business creation as much around this issue here to talk how important research is for Europe to stay Europe. I mean, one of my previous colleagues in the Danish Conservative Party, and he was actually the foreign minister and he was the chair for not long of our party, he said that Europe is the continent of people who doubt. And he really meant that very positively, because we have, because of our values, our freedom of academic, our freedom of speech, our open economy, we have, that is how we are the doubters, that we can do better tomorrow, but also that we share together that we must do better tomorrow, because we are a continent that can lead by our example, not because we want to be the leading example, but because we can see that we have the best toolbox also of values to do so in an agile way that also respects the fact that society is changing all the time. New knowledge creates new possibilities. So we don't need this totalitarian way of approaching our world and the way we are in it. So yes, I applaud very much, Tamsin, if you can initiate that together with the backstage of this event, that we open up this possibility. Thank you.
Thank you. I think that's a very positive message to get such an open and honest response to say, yes, absolutely, we need a research agenda that's been developed for that helps, shape the political ambition is there, the European Chips Act, but to make it happen, we need it, it's built on a strong academic foundation, and we need a research agenda. Jörg, I see you've got your hand up, and I'm going to also invite Daniel to respond on that as well in our last few minutes. Do we need a research agenda? Yes, Pernille says, yes, we want one.
Yes, of course, Pernille is right. We need a research agenda, but I think also we have to really remind ourselves, and I'm blessed with political naivety because so I can just say that we also have a task at hand here. The Chips Act is pretty concrete. We want to be at 20% by 2030, and as said before, the chip manufacturing lines are so complex that it's a huge companies that have the intimate knowledge about these things. So I think I would really, and maybe I'm also talking against, I'm employed at the university, but in this case, if we want to succeed there, the industry has to lead the research agenda, because otherwise we're doing research and we can do basic research and all that, and this is very necessary, and we should put more money into basic and more open research. But the European Chips Act is a very concrete thing, and it's the industry that has to make it happen, the additional 10%. So it has to be the industry in that case to tell the universities, we need knowledge there, we need knowledge there, we need to investigate this. Can you help us to investigate this part? And to make that happen, of course, there has to be some funding mechanisms, and even some money has to be channeled through the industry into the universities. I don't like that in principle, but if we want to get there, if we want to fulfill the task that we have set us here with the European Chips Act, I think this is the way to do, because otherwise we are not focused enough to get this additional 10%. So it's the industry that has to, together with the university, but the industry has to take the lead in making the research agenda. Otherwise we're doing a lot of nice research for the distant future, but we're not succeed with the European Chip Act.
Thank you. Daniel, you were nodding quite a lot. In our last, in 1 minute, please, could you just give your additional comment? Yes, we clearly need a research agenda, but we have to step outside our comfort zone and sometimes do the things that we're not very comfortable with to make it happen.
So I could state yes, and I could repeat what the others already said, but I would just shortly state that with regard to the mathematical logic, that it's the technical innovations around the CHIPS Act are necessary, but the humans are the sufficient parts and aspects in the whole game, and this is what should be implemented in the research agenda as well.
Thank you. Just again, in the same sort of 1 minute, Pierre Arnaud, if I could invite you to reflect on, it's becoming clear there needs to be a sort of consensus, a development of a research agenda that underpins and supports the CHIPS Act. You know, we've heard a strong welcome from the European Parliament. Is that something that would be welcome also within the Commission?
Sorry, a strong support for what? Sorry.
For developing a research agenda on the CHIPS Act.
Yes, of course it is. But I think that there are already ideas floating around, to be honest, and we want to work this way. But indeed, in the research agenda, and I would also very much agree with what Jörg said earlier, that we also need the industry to lead a bit and say what is relevant also for the future and what needs to be really developed, and that it's not a research which remains only research. I think that's I tried to explain in the intervention. Really, the objective is that we bring all that to the market and that we manage to make the link between research and industry.
Great. Well, I'm going to bring this webinar to a close. It's been extremely lively, extremely interesting. I thank you all for participating. We didn't have time for all of the questions that came in, which tells us that there is a strong interest. I want to say a thank you to all the members of our panel and for you to participating. What I've taken away from this is that this is the beginning of a conversation. And Tatiana said there are 2 more deep dives planned later this year. But before we had this meeting, I asked, you know, what could the conclusions be? Is it possible to talk about, you know, taking this conversation further if it becomes clear that that's what's required? And I think as your moderator, I would say that there needs to be a convening that happens that brings together the universities and others in the skills agenda with some of the industry agenda who take the draft Digital Chips Act and say this hugely ambitious thing was going to require us all to work differently in the future. What's our space for collaborating? How do we do things differently so that we can play our role? And if we can get a consensus and clear statement on that and go to the policymakers, then the investment will be there if we can show that we can make it happen. So I'm sure that the EuroTech Universities Network will be interested in convening this conversation further. I want to say a warm thank you all for participating and see you again at the next deep dive. Thank you and goodbye.